Welcome to the Module 4, Do's and Don'ts in Python. Writing code that simply works is only the first step. To be a professional developer, you must write code that is readable, maintainable, and efficient. In this module, we focus on the industry standard and best practices that separate beginners from professionals. We have a comprehensive agenda for this module. We will explore PEP 8, the official Python style guide, and master professional naming convention. We will also examine common Python mistakes and how to avoid them, discuss the DRY principle for code efficiency, cover debugging basics, and conclude with philosophy of writing clean, readable code. Introduction. In the professional world, clean code is not optional. It is the standard. As a developer, you spend more time reading code than writing it. Therefore, following community convention ensures that your work can be easily understood and maintained by others. This module is designed to help you transition from writing script to developing professional software. PEP 8, Python Official Style Guides. PEP 8 is the definitive style guide for Python. It provides the rules for how code should look on the page. Key recommendations include using your spaces per indentation level, limiting line to 79 characters to ensure readability on all screens, and using blank lines to separate functions and classes. Following PEP 8 makes your code instantly familiar to any Python developer in the world. Naming convention in Python. What's name, variable, function, classes, and constants? Naming is one of the most important aspects of clean code. In Python, we use snake underscore case for variables and functions, Pascal case for classes, and upper underscore case for constant. A variable name should always be descriptive. For example, user underscore age is much better than just X. Clear naming reduces the need for excessive comment and makes the logic self-explanatory. Common Python mistakes. Mistake every Python programmer must know and avoid. Mistake 1. Mutable default argument. For example, def add underscore item, open bracket, item, comma, my underscore list equals to curly bracket, close bracket. My underscore list dot append, open bracket, item, close bracket. Return my underscore list. Print add underscore item, curly bracket, open bracket, apple, close bracket. Hash, apple. Print add underscore item, open bracket, banana, close brackets. Correct. The correct one are here. That is def add underscore item, open bracket, item, my underscore list equals to none. If my underscore list is none, my underscore list equals to curly bracket, open curly bracket, close curly bracket. My underscore list dot append, open bracket, item, close bracket, return my list, return my underscore list, print as underscore item, open bracket, apple, close brackets. So that is the correct one. So also value equals to none. This is the wrong ones, and the correct one is also at the right. The left one is the wrong one, and the right one is the correct one. Common Python mistake part 2. More critical mistake and their correct alternative. Catching all exception too broadly. So try result equals 10 divided by 10. That is wrong. Try result equals to 10 divided by 0. Accept 0 division as E, print F error. So that is the correct one. And the first one here by the left, that's the wrong one. And the second one is the correct one. So also mistake 4, modifying a list while iterating over it. So this is wrong, and this is the correct one. Mistake with variables, scope, and string. So mistake 5, shadowing Python built-in names. So this is the wrong one, and this is the what? Correct one. That is using descriptive names. Wrong, using built-in names as variables. So the correct one is using descriptive names. So mistake 6, string concatenation inside loops. So that is not how you can do it. So the correct one is using join, past and Platonic. So this is how you can do it. The dry principle, don't repeat yourself. Write once, use everywhere. Dry, don't repeat yourself. Every piece of knowledge or logic should appear exactly once in a code base. Repeated code is primary source of bugs. A fix in one location may not be applied to all copies. So this is wrong by the left, and this is how you can do it by the right. Fewer bugs, easier to maintain, faster to update, cleaner code base, easier for teams to read. Debugging basics, finding and fixing errors in Python code. Syntax error, code cannot run, Python cannot paste it. Missing colon, parentheses, or wrong indentation. Runtime error, code starts but crashes during execution. Example, zero division error, index error, type error. Logical error, code runs without crashing but produces wrong result. Hardest to find, requires careful testing. Method 1, print debugging. Method 2, PDV, Python debugger. So that's how you can use them. Writing clean, readable code. Professional code quality standard. Use number 1, use meaningful variable names. Number 2, write doc string for all function. So that's how you can use it. Clean code checklist. Meaningful names, doc string, all functions, PEP 8 compliance, dry, no repeated logic, specific exception, tested with what? Unit test. Do's and don'ts, best practice summary. Follow 5-8 style guide consistently. Use snake underscore case for variable and functions. Use Pascal case for class names. Use upper underscore case for constant. Apply the dry principle. Write logic once. Write doc string for every function. Catch specific exception. Not all exceptions. Use is none instead of dash equal none. Use join for string concatenation in loops. Use breakpoints or prints to debug codes. X, don't use single letter or meaningless variable names. Don't use mutable default arguments in function. Don't shadow built-in names. List string dictionary, etc. Don't use bare except. Always specify the exception. Don't repeat logic. Wrap it in a function instead. Don't leave to-do comments in production code. Don't mix tabs and spaces for indentation. Don't use equal to compare with none. Don't concatenate string in a loop with plus. Don't commit code with testing it first. Practical code before and after professional cleanup. Same program, unprofessional versus professional version. So by the left is unprofessional, by the right is a professional and clean. So if you go through it, you'll understand how it is. Conclusion. This model has addressed one of the most important but frequently overlooked aspects of Python programming, writing code that is only functional but professional, clean, and maintainable. PEP 8 provides the universal standard for Python code style. The drive principle ensures that logic is defined once and reused, reducing bugs and maintenance costs. The detailed examination of common Python mistakes, mutable default, non-comparison, broad exception, list modification during iteration, and variable shadowing has equipped learners with knowledge to avoid costly errors. The before/after practical has demonstrated how dramatically code quality can be improved by applying this standard. Key takeaway: anyone can write code that works. A professional writes code that others can read, maintain, and trust.